Electrolysis is the separation of compounds into their elements using electricity or current. It requires a cell, battery, or power supply. Here I've drawn the diagram for a cell. The positive end of the cell is connected to the positive electrode, otherwise known as the anode. This is where anions go to be discharged. The negative part of the cell, shown by the small line, is connected to the negative electrode, or the cathode. This is where cations go to be discharged. The electrodes used in electrolysis have to be made of an inert material like platinum or graphite. Inert materials will not react with the electrolyte. The electrolyte is the liquid that conducts electricity, but it also contains the compound we wish to separate into elements. In my example, I'm using sodium chloride shown here. The L in brackets is the state symbol. The fact that it's liquid tells us that it's a molten compound we're dealing with. Ionic compounds must be molten, so the ions are free to move and allow charge to flow through the electrolyte. We can see here a solid state ionic compound melted with heat, allowing electricity to be conducted or current or charge to flow. Now let's work out the ionic charge of our ions. In sodium chloride we have sodium ions. Sodium is a group 1 element and so has a +1 charge when it's an ion. Chlorine is a group 7 element and so when it becomes an ion it has a -1 charge. It gains an electron. The symbol for the ions is shown here. What happens to the ions during electrolysis? The sodium ions have a positive charge and so are attracted to the negative electrode. Opposite charges attract. The sodium ions are reduced by gaining an electron to become sodium atoms. The electron moves down the cathode and into the cation. We can write a half equation to show this. Na plus E minus, which represents an electron, becomes Na, a neutral sodium atom. Sodium ions go to the negative electrode where they gain an electron and are reduced. Chloride ions are negative and so attracted to the positive anode, shown here in green. The chloride ions are oxidized at the anode to form chlorine gas. Now we need 2 chloride ions to form a chlorine molecule, chlorine gas, which is diatomic. So each chloride ion will release an electron at the anode. Here we can see 2 chloride ions arriving at the anode, releasing their electrons and joining together, forming a covalent bond to form a chlorine molecule. Chloride is discharged and chlorine produced at the anode. It's also oxidation because they're losing electrons. We can write a half equation to show what's happening. 2Cl minus goes to Cl2, which is the diatomic chlorine, and it releases 2 electrons. It's oxidized. Remember, oxidation is loss of electrons. You can test for the presence of chlorine gas at the positive electrode by using damp blue litmus. First, the damp blue litmus paper turns red. Then, the damp blue litmus paper will be bleached white. Chlorine acts as a bleach. So the change is red, then white, when you use damp blue litmus paper with chlorine gas. Let's try some exam questions on molten electrolysis. Okay, the question's about zinc. It shows the electrolysis of molten zinc chloride. Pause the video, have a go at this, and I'll go through the answers. Okay, guys, I'm going through the answers. It's good to use a highlighter to highlight the key points. We've got 2 plus zinc ions and chloride ions going to each electrode. Zinc moves towards the negative electrode where they gain electrons to produce zinc. Name the product. At the positive electrode. Well, at the positive electrode, chloride ions are going, so our product is going to be chlorine, or Cl2. We've just written this half equation, so it should be fresh in your mind. 2Cl minus goes to Cl2 plus 2E minus. 2 electrons are released. Describe what happens at the negative electrode. Well, we can see the zinc 2 plus ions going there. What do they pick up? They pick up 2 electrons. What do we call that? That's reduction. They become zinc atoms. Remember, the zinc ions are positive, the electrodes negative, and opposites attract. Let's get to the marks.